let's talk about a function generator now. Function generator is an output device. Our scope and meters and things are all input devices. We're reading some type of signal and looking at it. But the function generator is kind of the AC version of a DC power supply, and it's more than that, but that's a good starter way of looking at it. Um, so the function generator will allow us to do some things that we'll cover as we're going through. I'm going to describe the purpose and how to operate one of these. And one of the most important aspects is making sure that we're putting in what we should in order to be sure we're getting out what we should. So the old phrase of garbage in, garbage out is true here. If we have a bad signal going in, we're definitely going to have a bad signal going out. But if we can control the signal that's going in, then we'll know whether or not that bad signal is being created by the circuitry or not. And just like it says here, if we didn't have an antenna on a radio, if you've ever tried to pick up something without an antenna, even local stations become impossible to pick up. So, garbage in, garbage out. And so these function generators give us a known input so we can test the circuit. We have to be careful. We have to know what we're doing. And this would generally be a controlled environment where we know we can do whatever it is we're about to do, not just willy-nilly injecting a signal onto a board without knowing the repercussions of doing that. And these are also used to check hearing. You can actually hook a speaker up to the output and you can hear the different frequencies coming out of a function generator. And that's because they're used to be called years ago, I think, audio generators, but they are function generators, and they will put out sine waves and sawtooth waves and square waves and so forth and so on that you see here. And you'll be doing an experiment with that where we are controlling what we put in order to see if we're getting out what we should get out here. And so let's take a look. So they are part of the test equipment. And they come in all different varieties of things here. And it does produce accurate AC signals. So when I say it's very much akin to the DC power supply for AC, that's not a bad statement. But like I say, they're very much more versatile than a DC supply even. And again, whatever we put in, we know what we should be getting out. And again, it's going to be in a controlled environment. And the one thing we can see with a function generator is the frequency of the output signal. So when we are asked to set this thing, say, for 6 volts peak to peak at 20 kilohertz, that's easy as far as the frequency. We can see it on the dial in order to know that we've got the right peak to peak value. We're going to have another instrument, and we'll get there in a few minutes. And you see all these different controls and things on this particular one. And you can kind of see the different types. What you'll deal with mostly here is sine waves. You may deal with some of the others, and you'll definitely see it view some of the creations that it can make on an oscilloscope. So you can view the output of the function generator on a scope. So the function generator is creating this wave. The scope is merely measuring it, as I've said in the video before. When we change the view on the scope, we're not changing the output. We're only changing our view of the output. And this is where we would change the output. This is the device that can change the amplitude of the signal. It can change the frequency of the signal, or it can change both. All right, so we can go from a single hertz, 1 time per second, which is very slow. It's literally 1 Mississippi, 2 Mississippi, 3 Mississippi. So 1 hertz is pretty slow when we talk about an electronic waveform. And 1 kilohertz is 1,000 hertz, and 1 megahertz is 1 million hertz. So it has the versatility to create very high frequency output signals here. And we can generally go from 1 millivolt peak to peak all the way up to 10. That's going to vary by the instrument. And we've got 2 or 3 different kinds of function generators out there. So So again, your mileage may vary with the piece of equipment that you've got. And the DC offset voltage, the amount of DC voltage added to the waveform, is adjustable up to 10 volts. And we'll see that when you do the experiment. But basically, it's moving the AC to where it can potentially become DC. In other words, typically when we look at an AC sine wave, it's split right down the middle. But we can shift it more positive or shift it more negative, and that's the DC offset. The symmetry of the output signal is adjustable by changing the duty cycle of the signal. That may or may not be on the particular one. Again, these vary, but typically you're not going to be changing the waveform, but you can see what it means by symmetry. We're symmetrical, both sides being kind of equivalent. The left one here, the bottom peak being wider, the right one here, the bottom peak on the left being wider. So it just kind of depends on what you're trying to do there, but typically you're going to be working with sine waves. Signal can also be modulated. You can see here an example of that modulated signal. We take the input signal, the amplitude and frequency, we ride it on top of another wave, and it creates something like we see here. Unless you're getting into communication, it won't work with modulation much, but basically that's marrying two signals together, for lack of a better term. And you can click here. Change are regulated in terms of intensity, pitch, amplitude, frequency, or tone. A low frequency signal is often used to modulate the output signal. The high frequency is called the carrier, and radio and television use these signals. So again, unless you're in communications, you won't have to deal with that. AM/FM modulation using sine, square, or triangle, or sawtooth waves, depending on how you call it. So what is a function generator used for? It is not used for measuring. Remember, this is a device that does output. Scope would measure AC signals. Scope can measure DC, or a digital voltmeter can do that, but the function generator is used for producing AC signals. So that's pretty much it. We'll go through the summary real quick since we got a second. And producing these AC signals in various types, and 1 hertz down to tens of megahertz. So some very high frequency there. Again, the amplitude can vary from a very small amount to up to 10 volts peak to peak generally. And the DC offset and symmetry are adjustable, and the output signal will be modulated using AM and FM. I know, easy for me to say. So that kind of concludes function generators. They are neat devices in that we can create these signals that we need, sine waves, square waves, whatever the case might be, to troubleshoot equipment and provide a signal that we might not ordinarily be able to provide without the use of one of these things. So that's a function generator in about a 9-minute video. And as always, if you have questions, just let us know.